On January 8th, Miss Wakefield hit Mr. Garcia's car in the intersection between Taft and Dallas. Miss Wakefield's car weighs 69,700 newtons, and Mr. Garcia's car has a force of 13,600 newtons. These values can be used to find the coefficient of friction for Mr. Garcia's car. By finding the coefficient of friction for Mr. Garcia's car, we can find the coefficient of friction for Miss Wakefield's car by using the formula mu equals 70% of the coefficient of friction for Mr. Garcia's car.
Frictional force equals mu of Fn, and we're going to isolate mu now and making mu equal to Ff, which is frictional force, over Fn, normal force, and then mu is going to be equal to 100 newtons over 130 newtons, and then mu will equal 0.769. And now we're going to move on to the next equation of Ff, which is frictional force is equal to mu of Fn. But we can use mu of the truck is going to be equal to 0.7, which is 70%, as Carly mentioned before, of the car, and then mu of the truck will be equal to 0.7 or 70% of 0.69, which we had gotten from the car, and now the mu truck is going to be equal to.
Now let's move on to finding the acceleration of the car and the truck. So because we found the frictional force of both the car and the truck, we can use that value to find the acceleration. So we know that the formula is the frictional force is equal to the mass of both the truck and the car times the acceleration. So we will rewrite this equation to solve for A, which is acceleration is equal to the frictional force divided by the mass. So for the car, we know that the frictional force is equal to 10,458.4 newtons, and the mass is 1,387.775 kilograms. That our acceleration is equal to negative 7.536 meters per second squared. Moving on to the acceleration of the truck, we can use the same formula that we used for the car, which is acceleration is equal to the frictional force divided by the mass. We know that the frictional force of the truck is 37,498.6 newtons, and the mass is 7,112.243 kilograms. And that will give us the value of negative 5.272 meters per second squared for our acceleration of the truck. Now we will move on to finding the velocity before the collision. We will use the kinematic equation of v squared is equal to v naught squared, which is the initial velocity, plus 2 times acceleration, the change of x. We will plug in 0 for v squared, which is equal to the initial velocity squared, negative 7.536 meters per second squared, times 8.2. We found the value of the change of x, which was given because the car skidded a distance of 8.2 meters after the collision. We will isolate the initial velocity by subtracting it from both sides. That will give us the negative initial velocity is equal to 2 times negative 7.536 meters per second squared times 8.2. And now we will just plug this value in. The square root, because we will square root both sides, and that will give us the initial velocity value of 11.17 meters per second for the car. We will use the same formula and the same process to find the initial velocity for the truck. So the formula is v squared is equal to v naught squared plus 2a times the change of x. V squared is equal to 0, and we are solving for v naught squared, so we will leave that as v naught squared, plus 2 times the acceleration of the truck, which is negative 5.272 meters per second squared, times the change of x, which is 11, because the car skidded a distance of 11 meters after the collision. We will subtract v naught squared from both sides, which is equal to 2 times negative 0.272 meters per second squared times 11. We will square root both sides and solve for v naught, which will be equal to the square root of 2 times 5.272 meters per second squared times 11. And the final velocity of the truck is 10.77 meters per second.
Now we're going to use the law of conservation of momentum for the x direction. So first, label your objects, your car, your truck, and don't forget the total. Now we need to label a column for the initial x momentum. Now looking at the diagram, we can see that the car has an initial x momentum of 0 because it doesn't have anything in the x direction. Now if we look at the truck, we can see that it is its mass times its initial velocity, but we don't know its initial velocity. So we can simply find that by setting up the expression of its mass times velocity, or 7,112.245 times its initial velocity. Now, if we look at the diagram and look at its final x momentum, we can see that the car has a final x momentum of 1,387.775, which is its mass, times its velocity, 11.17 meters per second, times the cosine of the angle with which it skidded. Now we can set up the final x momentum of the truck like this too. Its mass, 7,112.245 kilograms, times 10.77. Its velocity times the cosine of the angle with which it skidded, which is also 7. So if we use the law of conservation of momentum to set up an equation that uses both sides, we can do 7,112.245 times the initial velocity of the truck is equal to the x momentums combined, which is 1,387.775 kilograms times 11.17 meters per second times the cosine of 33 plus 7,112.245 times 10.77 meters per second times the cosine of 7. Now, by doing simple algebra, we can find that the initial velocity is all of the right side divided by the left side, and that will give you 10.34 meters per second, the instant right after the collision.
Now we will find the initial velocity for the car going in the y direction. We will set up a momentum table with the objects, the y momentum, y initial momentum, and y direction final momentum. We have two objects, the car and the truck. $1,387.775 V naught sine 90. Now we know that the truck does not have a y momentum component for the initial velocity, so we will put a 0. For the y momentum final velocity, we know that the car skidded off in an angle of 33 degrees. So we will find the value of velocity using sine 33 degrees. So our formula will be 1,387.77 times 11.17, which is the final velocity of the car, times sine 33 degrees. 7,112.245 times 10.77 cosine 7. Now we will combine the values for the car and the truck in the initial y momentum, which will be 1,387.775 v naught sine 90 plus 0, because the truck does not have an initial y component. Now we'll move on to combining the final y components for the car and the truck, which will be 1,387.77 times 11.17 sine 33 degrees plus 7,112.245 times 10.77 times cosine 7.
What we concluded was that Garcia was lying because he was accelerating faster than possible for his car, and there was no way that Garcia could have stopped the rate of acceleration that he was going, and Miss Wakefield was going faster than what she had said, so both were found guilty.